infection manipulation assignment. And here the first part of the assignment, that's what I'm going to do with this video. The first part of the assignment is like printing something from the ASCII code. So here let's look at this. The 68HC11 can send and receive using variety of both serial and parallel methods. When using a microcontroller development, when you're using microcontroller development board, the PC is typically connected to it using an RS-232 asynchronous serial connection, a fast serial process predecessor of USB. Most PCs today don't have RS-232 connection anymore, so we will be using USB to serial adapter. We can then use the terminal in Mini IDE to view what the 68HC11 is sending to the PC. See assignment 5 on how it did this. Okay, in Trism 11 we have access to virtual serial receiver, and it is available in the view serial receiver menu. So I'm gonna open the Trism 11. Okay, this is Trism 11, and they say there's a virtual serial receiver. Okay, that's available in view and serial receiver, and this is the thing. Okay, now let's go and continue. Menu. Once you select this, a new window will appear showing three buttons available: setting, clear, and reset. So here you can see setting, clear, and reset available. You will likely to use clear button to purge any of the old data that was received earlier. This is the same as terminal clear window content option in Mini ID. RS-232 communication requires that both the sender and receiver are configured with the same parameters. The defaults here 9600 baud, no parity, 1 start bit, 8-bit data, 0 stop bits will be acceptable. Don't worry about what this means now. We will discuss it later in lectures. Today's USB automatically negotiates these type of values dynamically when connected, so we don't have to worry about doing with these newer devices on modern hardware. The receiver in Trism level, the terminal Mini ID both translate incoming data from the 68HC11 ASCII text and displays in their windows. They both translate 13, which translated 13, which ASCII for carriage return, a legacy term which told line printers to move printing head back to beginning of the line, followed by a 10, which is ASCII for the line feed, another legacy term which told printers to advance in line. As a way to force cursors to a new line, a subroutine has been supplied which you can call using ASR. With the value you wish to send to PC in ACCA is called serial send. Prior to doing this, we need to initialize the serial system in the 68HC11 by calling serial init. It sets up all the communication parameters to send out text to the PC. We can load ACCA with a value and call serial send. Then load ACCA with another value called serial send, and load ACCA with another value and call serial send, and so on. But with this result in large code whose size depends on how much information we want to transfer. For this section of the assignment, you will code a subroutine which will be passed the location in memory via the index register of where your name is stored in ASCII. The subroutine will read the location using index X, addressing to load in each letter of your name, and if it is in 0, then call the serial send subroutine to send it. If it's 0, it will leave the subroutine via the exit label. Please use your official name, which can be found in the UML site student Under profile, personal detail, it should be listed as first and last name. Send it that order. You can code your name using FCC form table of constant character as well as FCB form table of constant bytes for ASCII characters such as carriage return, line feet, and 0. It will specify the end of the text. Once your name is displayed, the code will go into endless loop, and that's it. Okay, so here what we have to do, we have to just print our name on this receiver using the code provided. Now I'm going to open the code provided, but before that, when you are doing this, you have to make sure that simulator reset h68ht11 is loading. This one is selected, and also you have to make sure that in memory configuration this one is selected to 68ht11e9. okay, now I'm going to open that. So I'm going to open over here, and this is what we have provided. And it comes with the instruction, and if I run this one now, let's see if it do something. Okay, so I getting this. Let's keep on running. I'm gonna see if it's printing anything on the screen. So to see that, I open serial receiver and then run again. Nothing happening. Okay, so I had to do something to the code according to the instruction to see if it's something happening. So first are they asking write your code to load ACCA with the memory. Okay, here also mentioned last part we have to decrypt cable. So endless open the assignment, extract file, and for this is extent only in 3.7.11 and only change the code where you are asked to insert provided. Okay, so we don't mess up with anything else. We only change where the codes are asked to be changed. So here this is the only part I'm seeing that has asked to do something. So I'm going to do something here. So write code to load ACCA with memory from 0x. Okay, here we already have x. Okay, so here write your code to load ACCA with memory 0 to x. Okay, so to do that, to load ACCA we have the term called LDAA, and I'm gonna follow exactly as it mentioned and then see if it's something happening. 0, x. Okay, I close with the semicolon right here. Then if ACCA is 0, leave the subroutine with an RTS. So if it's 0 exists, so we have to here have that comment. There's a command called BNE and BEQ. BEQ is like exit if it's not 0, but here we have to exit if it is 0. So that is BEQ. And then exit to leave the subroutine with RTS. So here this is the subroutine. So to go to that, I put exit because this is under the title of exit. I put that here. Otherwise, print ACA by calling serial send subroutine. So serial send is over here. Okay, we have to call that. Otherwise, print ACCA by calling the serial send subroutine. Okay, we have to just call that. So call that JSR serial send. That's the title. Okay, and then increment index register to increment the index register, we put inx. Okay, and jump back to the beginning of this function. Okay, so I'm gonna take one more code to this. We did the increment, we jump back to the beginning of this function. Okay, it mentioned this function, that's very careful. So jump serial text. Because this function name is serial text. Okay, now I'm gonna, that's, those are the only things that's provided, and the other one is the ASCII values are easily encoded by using XDC. That's the instruction. So let's run this one and see if something happening. I'm gonna reset and let's run this. Okay, this text is encoded in ASCII. Okay, so it's already doing the job for us. Here we have FCC, and this is what written over here, and that's the one printing, and it's already doing the job for us. Like, you don't have to go and convert each number. So if I want to print my name, that's what asks in the assignment. I put my name here, and now if I reset and run, printing my name. Okay, I can clear and do it again. Okay, that's the assignment is asking. So so do we need to go endless loop? I assume not. Let's see. I didn't have set breakpoint, but it's stopping after one. Okay. Yeah. Okay, this command is making it wait forever. BRA. So it's waiting forever after. So this is that the one required? Let's see. So there is serial receiver and the terminal both translate incoming data from 5680 and ASCII text displays the window. They've also translated a 13, which is ASCII for the carriage term, and legacy term, which told printers to move printer head back to the beginning of the line, followed by 10 in ASCII line feed, or so and so and so and so. To send the text, we can ACCA. Okay. Okay, here the part is coming. For the section of this assignment, you will code subroutine which will be passed location to memory index register where your name is stored in ASCII. The subroutine will read the location using index addressing the load in each letter of your name, and if it is in 0, then call serial send subroutine to send it. If it's 0, it will leave the subroutine via exit label. Please use your official name, which can find your details. It should be listed as first and last name. Send it in that order. You can code your name FCC from the level of constant character as well as FCB. Once your name, the code will go into endless loop. Oh, okay. Okay, there's a code actually stopping it from going endless loop, that BRA term. Yeah, just in case, let me see where is that. Yeah, it's over here. Yeah, if I remove this one, then it's gonna go forever. Like for example, if I put a semicolon for this and then execute, reset, and run. Okay, so it's giving some error message. So I don't want to mess up. So as the assignment required, change the value, like change the code where it's required, and I don't see any other place it's required to change something. So, and I did as it mentioned, SQL size. Okay, since the proceeding is memory reach, it's safe to. Okay, you can add non-text data as well. String 0 power register base address. Wait for the last byte to be sent. Post new return from. Okay, so this is the only thing required, and if we did that, then we are good. There's nothing else required. So let's reset this and make sure it works perfectly one more time. Wait a minute. Did I mess something up? Let me clear this. Let me reset this. Run it one more time. Oh shit, okay. Where is the A coming from? Okay, now it's working perfectly. And stop, run again. Doesn't work. So if I reset and run again. Okay, now it's working perfect. That's all I want. Okay, that's it. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.